Okay, so thank you and welcome for attending this afternoon session of the Homo scientificus europaeus meeting. This is the second of its kind. We'd like to thank our sponsors who have made this event possible. EuroScientist Foundation, the Ateneu, the Scientist Dating Forum, the Marie Curie Alumni Association, and Telapolis, who makes the connection with our remote speaker possible. Before we start this afternoon session, which is about responsible research and innovation and participative science, I'd like to start by setting up the scene a little bit. What we're going to talk about today affects the whole chain of events that come from the funding of research all the way to its application or its uses in wider society. So it's very important that we understand that the discussion is framed in the context whereby in every point from that change, from the decision, the point of decision of what projects get funded all the way to the practice of research into the time that science gets applied and used by other people, there is an element of inclusion of society which has been neglected for quite some time. And we're reaching a stage where there's a level of awareness in society that it's time that when research is happening out there, it doesn't happen in a vacuum, and it happens within society in mind, and preferably with the collaboration of citizens. And that collaboration, you will see in this panel, can take a lot of different forms. And I will not tell you more at this point, because all of my distinguished panel will tell you about examples of critical and concrete examples of how we can better engage science and society. So originally, in 2001, there's a philosopher and an agricultural scientist called René von Schönberg, who is currently working for the European Commission, who defined the concept of responsible research and innovation. And the way he defined it was very cryptic. I mean, it came across as a transparent, interactive process by which social actors and innovators become mutually responsive to each other with a view on the ethical acceptability, sustainability, and societal desirability of the innovation process and its marketable products, in order to allow proper embedding of scientific and technological advances in our society. This sounds so much like a mouthful that I think the Commission itself has moved on from that RRI concept, and there's been also a lot of dialogue around the concept, and we've moved on more towards an open science concept, which is a much more wider and encompassing concept. So the open science concept will be discussed in the second half of this afternoon. For now, we will just limit our discussion on how citizens can engage with the process of science, and conversely, how science can engage with citizens. And in order to initiate this session, I'd like to present our first speaker. So Toni Gabaldon, who's based here in Barcelona, and you will tell us a bit about who you are before starting your presentation.
Okay, so yeah, first of all, thank you for the organizers to invite me to this interesting roundtable with these colleagues that are engaged in very interesting projects. So I'm going to talk about my own experience as a researcher that gets involved in one citizen science project. So my background, I mean, is a typical scientist background. I studied biochemistry, then did a master's, PhD, postdoc, and then started my group here in CRG in 2008. And I was doing happily my research without the direct involvement of the citizens. And I was myself engaged in science communication, and always have been interested by science communication. But some years ago, I was involved in this project called Saca la Lengua, which is a project that tries to unveil the microbiome in our mouths, so the microbes that inhabit our mouth. So the idea how this project came about is a bit, as many things, a bit stochastic. It's like it was not a proper plan from the beginning. So it emerged from a dialogue between the CRG, my center, and La Caixa, the EuroCaixa Foundation from La Caixa. And they were discussing ideas about how to start a citizen science project in which life sciences could be done in conjunction with the citizens, because most of the citizen science projects that were running at the time involved, for instance, bird watching and naturalist projects, so people that could recognize different species or collect samples and this kind of thing. So we were thinking how we could have one project more related to the research we do in our center. Our center is a center that works in genomics. So we work with sequencing genomes and comparing genomes and understanding the role of the human genome and other genomes in disease and health. So we were discussing what to do, and many things came into the table. Like, of course, we wanted to work with high school students, because that's a good age also to communicate science. We chose one age frame in which in Spain they are deciding whether they do science or humanities. So we thought it may be a good moment to talk them about what science is, so they can maybe choose with a bit more information. And with several points were discussed, like because we do a lot of human genomics, but this had a lot of ethical implications and problems if you want to sequence people under the age of 18, to get the permissions, and it was complicated. So the idea of the microbiome came out, and also was a cool idea because recently the role of the microbes in our health and disease has been has been acknowledged recently. And now we have tools from genomics that we can analyze the microbes. So first, I think other speakers in this table will talk about what citizen science is. I'm not really an expert. There is several definitions. This is the one from the European Commission that was put on the table a couple of years ago. And if you read about it, it's about engagement in scientific research activities of scientists, of citizens at various levels. So it's not only about communicating to the citizens, but letting them get involved in the research at all levels, from the planning through the making and to the interpretation, and not necessarily that they do all, but they participate to the level that this is possible. And there are many other definitions, and several things are called citizen science. Some people discuss whether this is or not is citizen science, but we face this challenge on how we can get citizens involved in a project that involved, high throughput computation, the use of very expensive sequencing machines, and how to get them involved in as many parts of the project as possible. And this has been a challenge for us as a scientist, also to think ways in which they could get involved. So this is just a background of why we thought it was important. So there is a good rationale to study the oral microbiome. It's a very interesting habitat related with many diseases and quite unknown, especially at the younger population and so on. And we can investigate, so the idea was to investigate how this microbiome was changing depending on the dietary habits or hygiene habits or lifestyle of the people. So the project, we set up a website through which the people, normal citizens, could interact with the projects. They could see at every moment where the project was in. We were reporting on intermediate results, whether they were positive or even negatives. When things were failing, this was also reported. And they participated at different levels. So the first level in which they participated is to help us designing the questionnaire that the donors of the saliva will answer. We were asking them what were the factors that could be important for altering the microbiome in the mouth, and they put some ideas. And some of them could have been ideas that we ourselves could have think of, no? Like, importance of drinking sugary drinks or smoking and these kind of things. But other ideas were completely, out of the box that I would have never thought myself, like the effect of piercing, of having a piercing in the mouth. So this was one proposal, or going to a swimming pool often, like very often in the week, and so on. So this was input for us, and we included some of these questions in the questionnaires that were proposed directly by the citizens. Then the project involved collecting samples from many different cities and towns in Spain. So we went to big cities and really rural areas. And this was done through high schools and educational institutions. So thanks to EuroScientist, we get in touch with teachers at the different high schools. We set up some trainings for the teachers, usually biology teachers, that will get their students involved in the project, and they could use also this in their teaching of some of the concepts of biology. They could use this project to engage students into the areas of microbiology or genetics and so on. And so with this training, all the teachers were trained, and we were visiting the different high schools, and this was, there was a van from the project that was actually literally traveling around Spain, so for more than 8,000 kilometers. Luis Bejarano, the guy with the beard on the top, he was the one driving this van and going to the different high schools. He was giving a talk about the microbiome or about how to be a scientist. And then the students were donating saliva samples and also asking questions and also participating in the first phase of the collection of the sample, which is very basic, just centrifuging the samples that then were sent to the CRG. Yes. And so that was the project. Then, of course, the samples were sent to the CRG, where they were processed in very expensive machines that got the genome sequencing. And then the data, we made the data public to them through a series of challenges that they could participate. So we made different levels, like from the high school to university. They could choose different challenges. One was, for instance, they could getting the questions of the questionnaire, they could think of relationships and hypotheses to test. Like one example was some people, like in the towns, and the small towns, people drink more alcohol than in big cities. That was one question they wanted to address, and we were sending the data for them to test their hypotheses and so on. Another was like more a bioinformatics game in which they were getting the sequence and trying to infer which was the species. So that was the result of this first project, and we learned many things. Like, for instance, some of the questions had to be adapted because from the conception of a scientist, like asking whether you take antibiotics or not was a clear question. But then we realized, for instance, that in high school, people was thinking that antibiotics was any kind of medicine. So we got like incredible results, like 60% of people had taken antibiotics in the last weeks, and that could not be possible. And in one visit to one high school, I realized why this was. So it was a process of learning of how we, from our ivory tower, the scientists think about the important factors and how to formulate the questions, and then with the citizens, the interaction has to go through a process in which you have to make sure that they will get the point that you are trying to raise, and you have also to adapt to what they will expect. So the project was a success. People was very excited about this. They were very happy to participate, and now we are in the second phase of the project, in which we evolved also to study other groups of ages, different ages, and also in some disease conditions. So we are also working with patients associations, like with the Down syndrome and cystic fibrosis and celiac people and anorexia, also to study whether in these conditions the microbiome of the mouth is changed. And because this is a citizen science project, we want to do this not through the normal channels that we have in clinical studies, which means the hospitals, but directly talking to patients' associations. And this has been another challenge to get them involved, because sometimes you get a very positive response from the president of the association, which is a very activist person and really willing to help, but then it relies on the voluntary basis of all the individual patients. Each one has a different conditions and difficulties to do. No, so this had been a challenge. Also, the challenge has been to because we were directly talking to patients. This has created at some points problems with the doctors. No, which sometimes think that they are the ones that should decide what the patients participate in, which I think is an important aspect also when thinking about biomedical research. No, whether how we can make sure that patients are also engaged, not only through the doctors, but also as citizens. Yeah, and this is my own perspective. It's been challenging, but I think also very enriching to me. So I learned many things during this project, and it's not the best way to publish many papers, because we still have not get the paper. I think this is another aspect. It's more difficult also to publish something that emerges from a not so controlled experiment, let's say, that is done outside the lab with the participation of many different people with many different variables that are difficult to control. This is a challenge from the scientific point of view, but I think nevertheless it's worth it, and that's my perspective.
Thanks, Tony. I think that's a very good example of a very concrete research project that can be spun out into engagement in participative science. And I think our second panelist here today, Colomban, would also give us a very interesting view of how to engage with a wider audience. So I'll pass you on. 1 second.
Okay, so I am Colomban de Vargas. I'm in the Catalan session, but I am a Swiss oceanographer, in fact. And usually I work in Brittany, in Roscoff. And I'm just here in a sabbatical, so I'm spending a sabbatical in Barcelona for 1 year. And I will tell you a bit about a citizen project, which is, it's not totally a citizen project. I will explain you why. And in fact, I will tell you a bit the genesis of this project, the origin of this project. So we call this project Plankton Planet. And basically my obsession is to understand what is in this drop of water that you can see here on the planet Earth. And in fact, in this drop, you have all the water. That's the largest ecosystem on Earth, so it's the plankton. You have in this drop of a diameter of 1,400 meters, all the marine and fresh water, mostly marine water. And it's an ecosystem which is extraordinarily important for the climate. It has generated oxygen long time before the plants appeared, the terrestrial plants, and still today it generates half of the oxygen of the biosphere. So we are a few people who really wants to understand what is inside this water and how it works. And in fact, in every liter of this water, you have between 10 and 100 billion organisms, including viruses. And the beauty of plankton is that it contains organisms from a little bit of everything, from viruses, vesicles, viruses, bacteria, archaea, protists, and animals. So it's a little bit of everything. So but it's a very homogeneous and nice systems. So I was lucky in 2008 to meet Eric Karsanti, who is a group leader at EMBL in Germany, in Heidelberg. And together with him and Chris Bowler and Gabi Gorski in France, so we were mostly a French team, we aggregated on a sailing boat called Tara, and Tara is a boat that belongs to a French company, Agnès B, who is making clothes in France. I'm not sure if she's famous
They tend to export, I think.
at least she's very famous. In fact, it's funny, in Japan and China. That's where she makes most of her business. And she has this beautiful sailing boat. It's a big boat, 36 meters. And she has basically she offered us this boat to do whatever we wanted. But she the only restriction was that we do real good science. So we have We have been navigating on this boat for the last 10 years. In fact, it's still today, it's in the Pacific, sampling coral reefs. And we did the first 2 expeditions, were called Tara Oceans, and you can see them on this map. This was the first Tara Ocean expedition, this one, and then we did a tour of the Polar Circle in 2014. So this lasted 3 years and another year. And the beauty of this expedition is that we sampled plankton strictly the same way. We were stopping every 3 days at each station, and we sampled from viruses to animals, global ecosystems. So this was the first time we sampled, complex systems, oxygenic systems, that way for many years. And so we were quite successful in exploring the limit of the system. We published, we were very proud to publish a special issue of Science with 6 papers in Science in 2015. We have more papers last year. And then we started we did some nice discovery. I think, for instance, one of the discoveries that these cells, these big cells here that we call protists, are actually the most diverse piece of life in any systems. They are more diverse than protists and bacteria, virus or bacteria or animals. And we start to assemble these complex systems, the genes, the organism, and the environment into graphs. So we use graph to try to understand the shape of the ecosystems. But the problem of Tara is that we have not a lot of. So I think we have shown a nice way for a holosystemic view of the world. Now we have very little, spatiotemporal points. Because there is only 220 stations in all the cruise I've shown you. It costed quite a lot of money. I think the total cost was about 10 million euros. And so I realized 2 years ago that I didn't know, I'm not a sailor myself, but that you have in the ocean between 10 and 15,000 blue water sailing boats, so citizen sailors, that are at any given time crossing the ocean. So this is a fantastic resource for us, who love the ocean, to get samples. And this is really the big problem of oceanography, is to get samples. The cost of a classical oceanographic vessel is between 20 and 30,000 US dollars per day, every day. So it's super expensive. This is basically the main problem to understand plankton. It's the cost of sampling. So we have designed a little protocol, a very simple protocol, based on what we have built up in Tara Oceans for the last 10 years, and which consists in a very simple plankton net, 20 microns mesh size. So it collects about half the plankton, half the community. And then we have a little filtration device here that you can see. Everything is manual, so there is no electricity, no chemicals. We dry the plankton. The plankton is dried on a pan, because every boat has a little pan, so they can dry the plankton, the little galette, the plankton. And then they send it to us by regular mail, dried. And from this, basically, we can get, first, of course, I will show you our. So we had a test phase of this project with our planktonauts, that's the way we call them. So we had 20 teams, 25 teams actually, of planktonauts. We had our problem was really not to speak about the project, because they are really particular people. They are not really regular citizens. They are people who love the planet, who are often much better than us in engineering, in doing things. So I think they are going to very soon teach us how to do oceanography, they are very particular people who you don't need to explain them much. They do things extremely well because they are used to on their boat, So it's the Ferrari of the citizens scientists. And the idea of this first year was to have people really visit, going everywhere in the ocean. So we try to maximize, the conditions of these sailing boats. And so that what we got, in this map you have in red the samples we got in this first test year from Plankton Planet, and in blue the samples from Tara Oceans. So you can see that the coverage is even a bit bigger in Plankton Planet, and it cost nothing basically. Huh? The whole project, I think we got from an American foundation $60,000 US dollars, but including the sequencing, the salary of. So the boat is for free basically. Huh? So we got a nice sampling. You can see in this. I don't want to speak about that too much, but you can see that the black dot here correspond to plankton communities, samples in Plankton Planet. And the triangles are from Tara Oceans, and basically they match, the rise size fractions corresponding to Tara Oceans. So the samples are of very good quality. You can see in this plot here that each boat has brought back to the knowledge, that's the number of OTU of basically plankton genus that each boat has discovered, okay? So we are far from saturating yet the discovery of total number of plankton species, but it works. It works. Basically, we can have, we can know semi-quantitatively the plankton composition from any point on this planet from sailors. So we are quite happy, and now we are. So I'm going to a meeting in New Zealand in a couple of weeks, beginning of July, and we have assembled a team made of modelers, remote sensing people from doing omics, meta-omics, sailing, and also Manu Prakash. I don't know if you know Manu Prakash. He's the one who invented this origami microscope. He's doing millions of origamis. We want them to have a little planktoscope because they need to look at the plankton. Plankton is so beautiful that they need to look at the product of their fishing, and then they will like sampling more and more. And the idea then is to develop this project from New Zealand, Brittany, and San Diego, which are places very famous for sailing, and try to organize this loop in the oceans year after year or every other year, and really have a long-term monitoring of the world ocean to understand the acclimation, adaptation, and auto-organization of these complex communities. Thank you.
Thank you. I think these two examples are fairly convincing as to how the power of the crowd can transform research projects. And I think in both cases, you didn't seem to have much difficulty in convincing people to take part. But my question to you before we move on to the other panelists is, how did you assess the effectiveness and the standards of what the people were giving you back? I mean, in your case, Toni, it was different, but I mean, could you tell us about how you did the quality control and assess how effective this was in educating people as well in the process that we were following?
So you mean quality, like a follow-up, how we evaluated how well this was
perceived by the community, and whether you did it at all?
Yeah, we did it. So we had, we mostly got feedback, well, first directly because we were contacting them, all participants, because there was someone of us there in this, so they have a direct impression of what's their thing, so the idea, and then we also obtained feedback, especially from the teachers. So we got feedback from them, and also we measured the participation in the challenges that we were opening afterwards, as well as how many people was following the project through the website and so on. So this is how we kind of assess the responsiveness of the citizens and so on. But what we have pending is, and we have discussed, is we want to know whether participating in this process has impacted their own decisions as a citizen. So this we haven't done yet, but we have the contacts of all the people that participated, and this is something that we discussed. It will be nice to know whether to what point the students were changing their ideas about what to study later, or their perception, or whether they brush their teeth more often or less often, or they change their dietary habits because of what they learned from the project. So this is something that we have discussed, and we want to do it, and it will be nice to know. From individual cases, we know that you always have the very motivated students that then choose to do the project on the oral microbiome and contact you because they want more information and so on. But you always have these extreme isolated cases. But we want to kind of do this in a more standard way, yes.
Okay, thank you. That's very interesting. I would like to follow up on that on EuroScientist down the line for sure. Now I'm turning back to Colomban, and I'd be quite interested to hear about your experience. I know you said that you had a bit of an interesting audience already. They were already sold to these kind of ideas. But how did you motivate them? I mean, how did you interact with them, and how effective was this? Did they understand the scientific dimension, and to what extent?
Yeah, very much though, because I think they are kind of exceptional people, a bit, the people selling the world, But we had a problem, is that in fact we were asking the boat to slow down a lot, and this was a big problem because people selling, they hate actually slowing down. This is counterintuitive, and so we basically now we saw that quite a few boats, they sampled quite a lot at the beginning, and then they just let the net in the boat and didn't do any more. So now we are building up a net a high-speed net, basically a net with a small entrance that you will be able to tow while the boat is sailing. Then we think we have to also, develop these little tools for them to see the plankton. This is going to be very important because now they don't see anything, so it's a bit boring, but if they see each time they sample, if they see the beauty of the plankton, and it's changing every time you sample, I think we will get a lot of them really, because they will realize, these people have been sailing for years, and they never realized they were on a soup. And so this is quite exciting when the first time you look at, when you fall in this soup, sometimes you cannot go back. So.
Okay, well, I think we will keep further discussion for the debate part of this discussion, but I'm very excited to hear about a project led from Brittany, where I was born, and to see that, this is essentially an international collaboration, like most of the research nowadays, so it really is important to initiate it from a core expertise center of excellence, but then you reach out to the community to find the best people to build your team. And that seems to be the case as well with Toni. So without further ado, we're just going to move on to Rosina Malagrida, who will present to us her work in responsible research and innovation and participatory science here in Barcelona. So we just have to move on the computer. And it's all yours.
Well, thank you, and thanks for the previous presentations, which have been amazing to see how science is changing already, thanks to the public engagement and multi-stakeholder engagement. I was asked to start my presentation by saying why I was motivated to start in the field of RRI. And one of the reasons is that I work in an institute of research where we work mainly on HIV and AIDS, but also on other infectious diseases. And you may know that only 2 years after the first person was diagnosed by this illness, already the community was organized. In the United States, they wrote what they call the Denver Principles, and they already invited any person infected by the HIV to join this community and to fight for their rights and to try to make sure that the research was not done only with them, but also, not only for them, but also with them. So they said nothing about us without us. So we have a very strong community, and therefore it's been there for more than 30 years already, and we felt that we were not really giving an answer to this demand that was being there for such a long time. And we were very lucky to hear about RRI, also with a colleague that is sitting here, Nacho. We were reading together the call. He sent me an email with that call, and he said, why don't we go together to this call on responsible research and innovation? And what is responsible research and innovation about? Responsible research and innovation comes because there are loads of communities in the world, such as the citizen science communities, but also many other communities that start to realize that there is a need to reconsider the relationship between science and society, and that relying on events that focus on the public understanding what we decide and what we do is not enough. So it's very necessary to have big events and big festivals and to have the journals and the newspapers covering very good science, but it's not enough. And this is what the science and technology studies publications have been saying for a long time, and they have called it the deficit model. So the motivation was here for a long time. I was working in this deficit model sort of activities for a long time, but we didn't know. We knew that the scientific evidence was telling us that we were in a situation where we were in a deficit model, but we didn't know how we could change the situation. And RRI inspired us about that. So it told us that we don't need to to put this arrow going outside of the science and innovation system only, but that we need also to put the arrow the other way around. And this is very easy to do on a slide, but not easy to do in the reality. So basically what it's about is to make sure that we, the researchers and industry that are taking decisions inside the system, make sure that we share our responsibility with the stakeholders that have been traditionally left outside of the system. And these are, as we said this morning, civil society organizations, policymakers, and also, I think very interestingly, the education community, which sometimes we have left, even in universities where we have research and education living together, we very often see that there is a big gap between what is being taught and what is happening in the labs. So this is what inspired me, which was the first question that Sabine sent to us. And based on this, well, we were lucky to be together with La Caixa Foundation coordinating the RRI Tools project. And after that, we have been being involved in other European projects on RRI, like Enrich and also Inspire, that now is coordinating EuroScientist. We are collaborating with them on this, and also with another project called CRISH on training on RRI. And also, we had already a European project which was previous to the RRI new challenge, which was Explore Health, that we have also worked on it to make it evolve towards these new tendencies. It's an educational program to decrease the gap between research and education in the field of health, and that we run also together with La Caixa Foundation. So basically, this is not the new PowerPoint. Well, it doesn't matter, I will explain it based on it. Yeah, so basically what we did was to set up this living lab for health. And in this living lab, we have two sorts of activities. The ones that were traditionally in the deficit model, which are very important, which are science communication activities typical of any research institute, and also strong educational programs, as I said, to decrease the gap between research and education. So we try not to give only accommodated science, but also the science that is happening now in the laboratories. And we try to give this approach to research not only through educational resources like virtual experiments, videos, protocols of experiments to run experiments with real reagents from the labs, or card games to debate in the classrooms on the ethical, legal, and social aspects surrounding one biomedical research topic, but also we try to invite the students to participate in the research and innovation system, and we try to tell them that they are actors of these systems and that they can contribute to make it better. And how do we do that? So, for example, what we do are collaboration projects where we run community-based participatory research projects, and together we try to solve problems that they have through research, and we become peer researchers with them to define and execute the projects that we run. After we run the projects and we learn together about the issue that they are worried about, we do what we call participatory governance, because what we want is to join research with action. And therefore, what we do is we invite them, for example, to do a system analysis or any other methodology for participatory governance, where we make sure that we build together a policy agenda. Another example of this sort of projects that we do is, even before that, to build up the research agenda. So, for example, this year, we are doing a project called Co-Responsibility, where responsibility is written with HIV instead of a B. And in this co-responsibility, we are building together a research agenda on HIV prevention, where we have 16 schools, which means 600 students, but also we have different stakeholders. So we have a lot of CSOs and a lot of researchers, not only from our institutions, because the problem is complex, and this is one of the things that we learned from RRI, that we cannot tackle problems anymore by being divided in compartments, but that we need to see the problems as complex problems, not only involving the different stakeholders, but also being very interdisciplinary inside the academic wall. So we have identified 16 different lines of research, and we are working with these 16 research groups in different workshops to explore together and give priorities to the different research lines. And another field we find very important is also to build in any research institution, or maybe at topic level. So for us, in the field of HIV, we have created a community advisory board. Because I guess some of you may be thinking that some of the examples we are seeing today are amazing, but they cannot be applied to any field of research. So for example, we in our Institute of Research have very applied research or very basic research, and in both cases, sometimes it's not possible to do any of the examples I've just mentioned. So for these cases, we have a community advisory board where we make sure that we meet with the community, which means about 12 NGOs and also other research centers working in the same area, and we meet for a morning, like 3 or 4 hours, every 2 months, to make sure that we share with them our projects and that we listen to them so that we can respond to their needs and expectations. And finally, we do a lot of training as well. On RRI, we started that with RRI tools. We will continue it now with EuroScientist, with the CRISH project and with other partners in Europe, trying to spread the word and to train as many scientists and other stakeholders as we can to make sure that these methodologies are known worldwide, because we believe that things like Brexit, for example, is what we wouldn't like to be seeing in the field of science, and we have already been seeing some stakeholders that hear about RRI and that without knowing proper methodologies start building a participatory process that can be sometimes not leading to the results that we want. So that's for that reason, for example, in RRI tools, we built this toolkit, which is online and you can visit, and it has loads of different tools. I guess time is going, so I won't go in depth on it, but you can enter and you can see a lot of methodologies, and it's a growing community. You are invited to join and to share methodologies that you may know that work very well. So that's all from now. Thank you.
Thank you, Rosina. So I think we're going to move on directly to our next panelist, Raul Toran, who's Outreach Manager at the Barcelona Institute of Global Health. And he will tell us a bit about his own experience of participatory science. So we're just going to bring up the slides. And share it with you. Okay.
Thank you very much for the invitation. I will talk about RRI, but more focus on citizen science and our experience in this kind of projects. Well, citizen science, creating knowledge among all and for all. We saw more or less the definition about citizen science, but it's the science developed by non-professional scientists. This kind of project is possible because the participation of hundreds and thousands of people, like the project that you have seen before. Citizens have a key role in this kind of projects, interpreting and collecting this kind of data, but not only with the collecting data that we will see in these different levels. The objective of this kind of project is engaging people in order to participate in this kind of projects, and also has a very social impact for society. And one point that is important is some of these projects have been, the scientists have written some papers, and some have been published in important magazines like Nature and Science. There are 4 levels of citizens' science. The less participation level is the crowdsourcing. In this level, citizens only capture and process data. Is the less level. Then is the distributed intelligence, where citizens interpret this data, the results. The 3rd level is the participative science, where scientists participate defining the problems, the challenge, being themselves the scientists. And the most participative level is the collaborative science doing this process with the scientists. Well, in ISGGlobal, we have different projects related with citizen science. There are only a few. Well, you see, Sacalema, we collaborate with CRG in the first part of the project. Expect was a project led by ICFO in Castelldefels, and we participate also collaborating. But other project is the Citizens. It's about citizens observatories. EuroScientist, that is a project about how communicate the air pollution problem and how people think is the best way to communicate with other citizens and journalists, etc. PASTA project is about mobility, how to improve the mobility around the city. Inspires is a new project that have started this month, and with led by ISGGlobal and collaborating with other institutions like EuroScientist, Université de Lyon, and a lot of collaborators. And it's about science shops. If you want, we can talk about what is science shops and this model. ISGGlobal is member of Barcelona Citizen Science Office, that is from the ICUB. And it's very interesting that ICUB, Instituto de Cultura de Barcelona, has developing a new kind of citizens projects in the city, in all the territory, and they want to collaborate with scientists in order to create these projects around the city. And I will talk about one of these projects that we have developed. We have named this project Citizens BCN Experience. And then the thing is, the researchers, in collaboration with El Centre Civics and the citizens around one area, develop a citizen science project. And in our case, we collaborate with an institute, Ernest Lluch, and a classroom, and the students must decide which kind of project they must do. In our case, about pollution. We bring the sensors in order to measure the pollution. It works with an app. Then they need to have a mobile with the system, with the app, and also a manual in order to explain how it works and that. But all the project, the routes that are polluted or not. If they, for example, they decided how to arrive at the school in the less polluted way, most polluted way, shorter or larger, then decided how they want to do the experiment. And they do the experiment, and we only give the knowledge, but they do all the process, like scientists. And the final results, in order not to explain all, they have positive results and negative aspects of this kind of projects. Well, the most important they were very enthusiastic with this kind of research. They know that it was an interdisciplinary work. That they need to work with different areas, and also we found the scientists that was a very useful tool for citizens. And the negative aspect of this kind of project is the creation of false expectations, because they think, wow, we will have a very good results, the hypothesis will be okay, and then maybe the hypothesis at the end was a mess. And also the lack of positive results, because maybe they have, if I go with this route, I will have a lot of pollution. But in our case, for example, it was a problem with the sensors, and the sensors give wrong information. But we think that the students learn that sometimes the technology fails, and then it's a very good, because maybe they can make false process in order to have the result that they want. But the thing is, they have learned that you can fail in your experiment, and it's not a problem. And also the lack of communication between sometimes the scientists and the group. But I think these kind of projects are very interesting in order to engage the students, and they want to learn more about science, and for us, it's all. Thank you.
Okay, thank you. So we will move on to Helena Gonzales right away, and then we'll have the discussion, debate. So I'll load the presentation. So there you go.
Thank you.
Thank you.
Okay, thank you very much. Yeah, my name is Helena, and I'm the director of a very small company of science communication called Big Bang. Maybe some of you already heard about it. We are all of us are scientists. Most of us have a PhD in different areas of science, and we communicate science using different ways. Maybe one of the most successful ways that we use is performance-based activities. It means theater, especially stand-up comedy and clown. And during the years that we have been communicating science through these disciplines, we realized that they are very effective when communicated science with teenagers in high schools. So let me explain how these stand-up comedy shows happen. So we, scientists, go to the high schools and talk about different topics about science, and then we open a turn in which students can ask whatever they want about science, about the different topics that have been happening there, or about whatever. And we realize that the students are really engaged in these ethical issues, in these gender topics, in which ways you have to follow to reach a scientific career, and that's, in the end, RRI. So that's why we decided to start a project called Perform, in which we address all these problems, gender issues, critical thinking, self-reflection, science as a method in high schools. This project has been coordinating here in Spain by University La UOC, Universitat Oberta de Catalunya, and we are part of the project in which we wanted to generate some performance-based activities talking about different RRI topics, but we wanted to involve teenagers and high school students from the beginning of the process. So the first thing to do is to talk to them about their fears, their concerns, what they know about science, what they want to know about science. And that's why we did a series of participatory workshops in high schools with teenagers talking about all these issues. We wanted to reflect with them about ethical issues in science, what they think about that, about gender issues, the communications between science and society, societal challenges that science can face, and also scientific stereotypes, because we realize that it's a very big barrier for teenagers to choose a scientific career. So we analyzed of the results that we had in these exploratory workshops, and then we designed a series of guidelines to can make a performance-based activity, including all these topics that are relevant for high school students. But not only that, it was our first stage. In our second stage, we not only developed these performances, but we wanted the high school students to develop their own performances talking about all these topics. These are the participatory workshops that we are now implementing in high schools here in Spain, but also in different cultural contexts in the UK and in France. In fact, what we want is to have a participatory process in the high schools in which not only students, but also teachers and scientists can participate to develop these performance-based activities. And I'm saying performance-based because here in Spain we are doing stand-up comedy, but there are also other disciplines around the different countries, such as clown, improv theater, and busking. So the discoveries are that, in fact, the teenagers are much more engaged with science when you talk about these topics and not only concepts and science itself. So it was a very good discovery that they want to know about the scientific career, the problems with gender, the problems with the ethical issues, so it was good. We expected to have more researchers engaged in the process because, as Toni said, they only have some very motivated students to participate in the process. We didn't have this problem with the students as long as we are going into the high schools, but we had these problems with researchers. It's very difficult to have researchers motivated enough to participate in all the participatory workshops and to go into the schools and to talk to teenagers, 13, 14 years old, about all these topics and to be honest about that. So it was one of our main problems, to have motivated researchers. And our future plans is to try to implement all these RRI topics inside the formal education. I mean, we also have in this project Perform, one more package that is about policymakers and how to include all these results inside the education in a European level. So we are trying now to include all these results that we have about the expectation and the needs of the teenagers in the formal education. And that's it.
Thank you. So I think we're going to swiftly move on to the debate. And I think there's one point that you did just now, saying that one of the issues was to motivate scientists. And I'd like to extend that question to other panelists as to what your experience has been. I don't know if you, Colomban, you want to start in trying to motivate other people in your team in making sure that they educate those citizen scientists to make sure they contribute to your project.
Yeah, well, the project I have presented was a small scale, but I think, yes, I guess it can be a problem to get the people out of their computer. Or,
did you encounter problems? I mean, did you experience it firsthand?
In marine science, I would say I think it's not a big problem because we have a propension to go to the field, and I think there is a selection for people who like to go at sea, and okay. So it's not as difficult as probably as in other lab, I would say.
Right. So perhaps Toni or Raul or
always it's difficult because researchers has little time because they are always preparing projects. But we have very interested researchers to participate. Yes.
So my experience, I mean. Yeah, in my institute, I think it depends on the person. I think in general, many colleagues do see this as, they don't understand really why we are engaged in these things because they just wonder, so when is the paper coming out? Is that going to be Science or Nature? And if not, why you are doing the whole thing? No, because I see this is a lot of work. It's actually more work than a standard research project because you have to deal with all these additional variables. You are out of your comfort zone. So it really requires an effort, which is also then not really appreciated by the system. No, the system, they choose to do promotion of researchers, or they don't really count this. No, they just count publications and impact factors and these kind of things. So either you are motivated because you are interested in this because from personal reasons, no, because it's providing you some interesting experiences and you learn yourself, or it's very difficult that you will do this because you have already a lot of stress to publish, to do the best you can to get funding, and these things is kind of out of that way. So I think this is an important thought because we need to find ways, if we think this should be implemented, we need to find ways in which this is kind of supported and help and people get also credit for doing these kind of things.
I think that's a very important point. I mean, there's been a lot of discussion around alt metrics, so alternative way of measuring the performance of scientists. Perhaps someone else wants to comment on this on the panel?
No, you know. Just to say that in our case, the main problem was the PI. and not the researcher itself. So maybe we need to find some ways also, not for the researcher, but for the whole community to understand that it's important.
So you mean the PI was
The PI
not
of the
happy
lab.
that their team members were participating?
Exactly, because those are activities that are implementing during the morning.
Yeah.
So it means that for one whole morning, your PhD or your postdoc is going to be out of the lab. So that's true. And yeah.
Yeah.
And that links with the question. I think your question was about metrics and evaluation,
Exactly.
I guess. So yeah, there is a big debate in different communities around the world on reconsidering the way research is being evaluated and the need to give more relevance to societal issues. And therefore, to outreach activities, this would be solved with this. It's already there in a lot of countries, like the UK, for example, and now the minister in Spain has also written it as a requisite, so it will help. But we need it to be communicated and to make sure that the PIs know that this is a requisite already. But I think that the evaluation should not only consider outreach activities, but also RRI, so at least that any research group participates in the different phases of the process in different engagement methodologies, like considering the research agenda setting during the process of defining and executing the project, and also at implementation level if we are lucky and we have something to implement, and to make sure that we are collaborating in these different steps with our researchers.
Okay. Any more comments?
You know, it made me think about the beginning of Tara Oceans. You know, when we started, we were a team of very weird people because there was Eric from EMBL and people from Genoscope, and so we were not from the oceanography community. And at the beginning, we were really accused by colleagues, you know, to go and have fun at sea, and because it was very mediatic. We had a full, you know, season of a show called Thalassa in France, which is very famous. So every Friday we were on the primetime show, and so people were really thinking we were just, you know, doing, you know, having fun and making, and we were really, you know, some people wrote to the CNRS, you know, to stop this and to, very aggressive. I think a lot of scientists still believe that if you do this, it's just not serious, and
But there was also a comment made by Toni that people are being pushed out of their comfort zone in the scientific community, and I think that's a very important aspect. Perhaps someone else wants to comment about that. You know, how essentially you're doing something that's not being part of your formal evaluation, and yet, I mean, is there an upside to this? I mean, there must be if you're doing it. Do you have any?
So what do you mean? If there is
what was the greatest compensation, the greatest fulfillment you got from this project, essentially?
So you open your mind. So I think that's very, for a scientist, when you realize you are looking at things from a narrow perspective, and something makes you change and look at the same thing from a broader perspective, I think this is very satisfying as a scientist. Just you realize you open your mind, you were blocked in a path, and now you have a broader vision. To me, that's enough of the experience. And then also when I talk to the people, it's really, you know, when you find a student that is motivated and is asking you, like, really, I mean, we went in the Cambridge Science Festival, and we had a kid of, I think he was 5 years old, he was 5 years old, and we were talking about the microbiome, and he asked the question, so what if we remove the microbiome from a person? So what's going to happen? 5 years old, you see this thing, and then I think it blows my mind when I see these kind of things, and that's, as a personal experience, is the beauty of people thinking from a fresh perspective onto the same problem that you are looking at from after hours of studies and a lot of papers read. No? So
we will open to the floor. Some question. Do we have a microphone somewhere? Yes, it's coming. While we get organized, I just have another quick question. Was quality control ever an issue when you get people who are not trained as scientists to gather samples for you? I don't know. if either.
Well, from our perspective, I mean, to me it was the first time I was obtaining data through a questionnaire, so we got help from the CREAL. So they are more experts so they help us in designing the questionnaire and so on. But then collecting the data through this, and also when you target different groups of population, it's not the same a teenager in the school with a teacher around, that the person that goes to a science museum to see some talk. I think this is something we have learned in the hard way, like many questions we could not use because we did not formulate it in the proper way, because we were thinking we need this data, we want this data, we ask this data. But we didn't think, is this the proper way to ask this data to get the response we need, like the fair response and so on. So to us was, we learned this in the hard way. We had to discard many questions of the questionnaire because they were useless for the study because they were not reliable.
Very good.
I can say the same. I think the data itself, when sequencing, it's not a big deal because the data speak by itself, and when you get big numbers, you can immediately detect the outliers. So but the context, the contextual data is a problem. Often you don't realize that very simple question will be a big deal.
Yes.
Okay.
That's,
so we're going to the floor.
My question was actually related to that, which is, to what extent did you involve social sciences?
So we did at the beginning. We contacted them because we knew we were not experts in this aspect. So we discussed with them about how to go to the questionnaire, and so I think it was better than what we would have designed on our own. But still, by going to the field and getting the responses, then you realize it's too long. Some of the questions were a bit not well understood, and this kind of thing. So I think it's a learning process as well.
And did you feed back to the social scientists?
Yes, so we informally, but yeah, that's something we can do better, yeah.
No. In our case, the 16 lines of research that we have identified for the HIV prevention contemplate a lot of different disciplines, including social sciences. And I remember talking to one director of a big public health institute, and he asking me 3 times the same question, which is, you that are working in this institute where you don't have this sort of research, you are going to do a project that deals with this sort of research? And I said, yes, because it's not my fault that my research center has walls. The problem is complex. And then he asked again the same question. So we can realize that they are getting out of the we are all getting out of our comfort zone, and that we must make sure that then it's not us just asking the social scientists to help, but trying to co-construct and work together.
In our case, all the evaluation of the process is mainly made by social scientists, because at the end of the day, what we want with this project is to raise scientific vocations and to involve the students. So we need social scientists taking care of that.
Yeah, but we cannot consider social scientists as a kind of engineers who help us do what we do in the right way. I mean, social science is part of science, so there are issues about social science for which participatory attitudes are relevant. So you can't the way you're considering social science is like, we have a web designer to do our website, we have a social scientist to do our questionnaire, and I don't think this is right.
That's the reason why I think it's so important to dedicate a lot of time to define the problem and the research question that we want to answer, and to make sure that this time is given to spaces for collaborative deliberation between the different stakeholders, but also within the academic world with the different disciplines. So all being able to respond to each other to make sure we can all agree at the end on the research question and what can the different disciplines contribute to it. So this is, for example, the Agency of Innovation in Sweden has radically changed the way they found research and innovation, and they give loans, money for projects for 8 or 9 months dedicated to make sure that the consortium is built and that the problem is defined and the research question is decided. So as you can see, 8 or 9 months would be the equivalent when we write a European project How do we do it? Do we really manage to have so many people collaborating and jointly deciding what we are going to do? Of course, we try to do it, but we don't have 8 or 9 months and funding to do it properly. So definitely this is, I think it's a must to have social sciences, but not only social scientists, but different disciplines together and with collaborative deliberation methodologies.
Okay. Any more questions? Any more comments? Okay, so...
One there.
Yes. Please.
We were discussing about rewards for scientists. I was wondering rewards for the citizens or the sailors or the kids who participated in the research. If you can give a few examples how you recognize them in the papers or prizes, because that's an issue under debate in citizen science.
For example, in our case, the students that have participated in this project now have presented the project in a contest, and maybe they go to the final, and they made a presentation of the results in an auditorium like this with 80 people, and they was very happy to present the results like they were the scientists. And other projects, for example, that students have participated, we invite them, for example, to the EuroScientist, to the museum. We try to give some little presents, but also they make them also imply in the research. And also, for example, the students have participated in some research. We put in the papers the name of schools, for example.
So in our case, we collected about 2,000 samples and overall participated more than 3,000. So it's impossible that we put everyone in the paper, anyone in one whole week. So we consider including names in the paper when the paper comes out. If there's one of the questions that someone proposed that at the end is found relevant with a correlation, and that's going to be reported in the paper, the person that proposed that question will be co-author. Then we had also challenges in which teams were formed and they were given prizes. And because the project this also involves the implication of social scientists, we were limited in funding, so we could do what we could do. So the prizes were like one of the kids could visit the CRG and be embedded in a research lab for 2 weeks. So that was an experience for the winner of one of the challenges. For the others, the challenge was about visualization of data. So we gave to the high school of that team the opportunity to have one speech from someone professional for this. So we try to give prizes, like asking people, can you go on to the high school? So yeah, they got some rewards, yeah. But in the case of massive participation, sometimes difficult to... Yeah.
In our case, it's quite simple because the prize is to have a theater play that they can perform in front of families and in front of the rest of the students of the high school. So they are very motivated with this issue. And at the end, this is the final present of the whole process.
Okay, so one last question, unless there's any more from the floor. I just wanted to know if, with the benefit of hindsight, would you have involved representative of the public, people who you have associated with your research project at the funding stage, just to get that bigger picture? Would you have benefited from having their input or their perspective on what you were trying to do when you were looking for funding for these kind of projects?
I'm not sure.
There's a lot of discussion in the circle that citizens should be involved in at the funding stage to decide what should be funded. And I was wondering whether, with the benefit of hindsight, having involved these people downstream, would you have done things differently if you had consulted them before when you were writing your research grant? I mean, because that's quite controversial.
In our case, we did that actually because the reason why last year, for example, we worked on mental health with this community-based research project I mentioned on participatory governance. So students in that case ended up the process after doing the community-based research. They did the system analysis and governance, so a policy agenda with recommendations. So their engagement was from the beginning in deciding every single step, but also the topic was decided by them because the year previously we asked 1,000 students in their schools what topics would they consider to work on in terms of health. And mental health was one of them, and the second one that won was HIV/AIDS. So that's the reason why we worked the first year on mental health, and the second year we are working on this. And we keep on meeting with their teachers, and the teachers invite them to participate as well, and we have a Basecamp, a platform where we continuously communicate to each other to make sure that we are responding to each other's needs.
Okay. Any more comments on this point?
Well, it's very complicated to align the interest of citizens with the research, but if you work with, in the beginning, like science shops, deciding the questions and avoiding future problems. For example, when in the first research with in English, I don't know how to remember, genetic modified plants. Yeah, exactly. People don't know this technology and then are afraid about this technology. And then if you are starting the research about, for example, nanotechnology or biomedicine at the beginning, people can know all the advantages, also maybe the problems, but you can improve the research and do the research without the fear. And then I think it's very interesting, this kind of project about citizen science and other initiatives in order to avoid the future problem.
Okay. So I think...
I think it's important to consider letting them is not just letting them decide. I mean, it's letting them participate in the decision process. So I think it all has to be about a dialogue in which we take their opinion in their account, because we are used to listen to the politicians who decide what we have to do, what are the priorities and the priority axis in the H2020, and this come only indirectly through the citizens that are completely left apart of that. So I think it's very important that we also listen to them. And this is very different from just making a poll on what we should do research on, but it should come after a dialogue in which they learn, they ask, there is, and after that interaction, their opinion is useful.
Okay. So, any more last word? No, I think we've covered the topic quite extensively. I'd like to thank all our panelists today for taking the time off their busy schedule, either as scientists or people involved in making sure greater participation happens in research. And we will have a 5 minutes break and then reconvene for the next panel. Thank you very much. Thanks to all of you.